Hello students, today we are discussing about the equilibrium in the buffer solution. Buffer solution. So what is the meaning is that sir buffer solution is there here means the buffer solution is nothing but you have heard the name that buffer solution. What is the use of this buffer solution here means? So you consider that some of the reactions are there. They are taking place only in a certain temperature. If that temperature is not satisfied here means that not meet here means so that what happens here the reaction is not taking place here. Like that only some reactions are taking place in some pH only. Certain pH only. Suppose the pH is 4 is there. Suppose anyone a reaction that is taking place in a pH of what only 4 is there here. Means that reaction takes place only that pH 4 only. If you increase the pH or decrease the pH, what happens here? The reaction is not taking place there. So to minimize, to control what pH of the solution, we are using the buffer solutions here. So what is the meaning is there sir here? So I will write down the definition. The buffer solution. A buffer solution is a solution. A buffer solution is a solution. A buffer solution is a solution which resists the change in pH, on dilution or addition of small amount of an acid or alkali. Okay, that is the definition I have written here. What is the definition of buffer solution here? You see here, a buffer solution is a solution which resists the change in the pH on dilution or addition of small amount of acid or alkalis. So suppose if you are taking that any one reaction is going on here in the beaker, any one reaction is going on. Okay, suppose they consider any one reaction, that is A plus B, it gives what? C plus D. That reaction is going on this beaker here. Okay, so this beaker if it is undergoing here means the temperature it should be maintained pH of what? Suppose 4.75 is there. 4.75 means that if this reaction A plus B combines to what? C plus D, when it is taking place here means when the pH of the solution is about what? 4.75. Suppose if you added the buffer solution here, what is the buffer solution it will do here means, so it will does not changes the pH of the solution here. If you added any buffer solution in this beaker, so then what happens here if this reaction is going on this beaker here means, so this buffer it will resist the change in the pH here. Okay, when you are adding the small amount of acid also, the pH does not changes here. If you are adding the small amount of base, then also the pH will not changes here. Suppose we added some amount of water, then also what happens here? Small amount of water we added also, the pH will not be changes here. So that is what we are calling it as a buffer solution. What is the buffer solution is there here means it will maintain the pH of this solution up to one level here. Suppose the example I will write down here. What are the examples of example 1? A mixture of acetic acid and sodium acetate. A mixture of acetic acid and sodium acetate. Sodium acetate, sodium acetate, sodium acetate. Acetic acid and sodium acetate acts as a buffer, acts as a buffer, acts as a buffer around 4 point around of pH around pH 4.75. Means suppose the mixture of you are taking acetic acid and sodium acetate. When you are taking mixture of acetic acid and sodium acetate, so buffer solution you are making. For the buffer solution we are making what? We require acetic acid and sodium acetate. So many chemicals also you can take care. The one example I have given is the example for what? Acetic acid and sodium acetate. It acts as a buffer around what? pH 4.75. Suppose in the solution A plus B, C is converted into C plus D here. When you are adding this buffer solution, which buffer solution here? Acetic acid and sodium acetate buffer solution. Then what happens here? The pH of the solution, it maintains what? Only 4.75. Suppose if you are added the acid, then also the pH of the solution will not changes here. Suppose if you are added the base, small amount of base you are added to the solution, it does not change here. Why it does not change? Because of the presence of what? Because of the presence of buffer solution here. So this reaction takes place continuously. When the pH of the solution is increased means or decreased means what? This reaction does not take place here. To take place this reaction, to continue this reaction, you have to add what? Buffer solution here. There are so many types of buffer solutions are there here. I have given one example here. Next one, the second example, you can also write down that one. The second example is there here is the mixture of a mixture of ammonium chloride NH4Cl and NH4OH acts as a buffer solution, acts as a buffer around what? Around pH, around the pH 9.25. When you are added this ammonium chloride and ammonium hydroxide buffer solution into this one, what happens here? It maintains the pH of what? 9.2 only. So it does not increase or decrease the pH of the solution. So this is the what? Buffer solution. In the easily way how to understand the buffer solution? The buffer solution is a solution which resists the change in the pH of the solution by dilution or by addition of acid or an alkalis. So this is called what we are calling as a buffer solution. Okay. Next one you are having the solubility product. Next one, solubility product. Next one, solubility product. Solubility product. What is the meaning of this solubility product here? The solubility product, I will write down the definition first. What is the meaning of solubility product is there here? The solubility product of a salt, the solubility product of salt at a given temperature is the solubility product of a salt at a given temperature is equal to molar concentration of its ions, molar concentration of its ion, molar concentration of its ions in the saturated solution. Molar concentration of its ion in the saturated solution. Solution with each concentration term is raised to the power of its stoichiometric coefficient. So this is what we are calling to say there is a solubility product. What is the meaning of solubility product, sir? Here is the process of solubility product of salt at a given temperature is equal to the molar concentration of its ions in the saturated solution with each concentration term is raised to the power equal to the stoichiometric coefficient. So this is what we are calling to say there is a solubility product, sir. So sir, can you give the example for here? So take the solubility product of this AgCl, silver chloride here, AgCl. It is in the form of solid is there here. Okay. So when you are dissolving in a water, that is aqueous. Okay. So when you are dissolving in a water, then what happens here? Then it starts dissolving to give what? Ag plus. It gives the Ag plus, that is in the form of, it is present in the form of aqueous form. Next, it dissociates to give what? Cl minus. Okay. So silver chloride when dissolved in a water, so it gives what? Silver ions and chlorine ions here. So write down the solubility product of this reaction in it. How to write down this one? That is what write down what? That is the KSP. That is what write down what? That is the KSP. K is equal to what you write down first? You write down K. That is what? The molar concentration of its ions they are given. Molar concentration of ions means what? These are the ions are there. This is the molecule. This is the what? Ion is there. Then you have to write down first ions here. Ag plus into Cl minus divided by AgCl. It is in the form of what? Solid is there. It is in the form of solid is there. Suppose when they are present in the form of pure solid or pure liquid, you have to take it what? Unity. That is one you have to take. That is what AgCl in the form of solid. That is we are taking as a unity here. We are taking as a unity. So when you are taking as a unity here, means so what is the value you are getting here? So that is we have to write down is what? KSP is equal to KSP means what? Solubility product. Okay. KSP is equal to what? That is the Ag plus into Cl minus. So this is what we are calling as a solubility product of AgCl. This is what we are calling as a solubility product of AgCl. So how we are writing this solubility product of AgCl here? That is you have to see here in this reaction. No any power is there here. No any stoichiometric coefficient is there. Only one is there here. In this side, this side, Ag it is having only one is there. So Cl it is having one is there here. So I had raised the power to the one only. Suppose if you are having the 2 is there here, means 2 Ag is there. Then how to write on this one? You have to write on what? Ag square. That is that solubility product they are told here only. With each concentration is raised to the power of stoichiometric coefficients. So here stoichiometric coefficient 1 is there, here also 1 is there. I have raised to the power only 1 here. Okay. So this is about the what? The solubility product here. Next one. Next one is relationship between solubility product and solubility product and solubility. Okay. So how to write down here the relationship between the solubility product and solubility? Here means you have to take one example here. There is the first one I will write down here between the relationship between here is an AB type of electrolytes. AB type of electrolytes. AB type of electrolytes. So in the AB type of electrolytes, what happens here? You see here, that is the example for AB. AB means only one cation or one anion. So that is the example for AB type of cations is what? The example is that is the LiF, lithium fluoride. LiF. Next one is AgCl. Okay. So you see here the AB type of electrolyte is there means so you have to take what AB when it undergoing the dissociation means when you are adding to the water, then when it is in the form of solid is there here. When you are adding into the water, that is the aqueous form, then it gives what? Then it gives the that is the A plus S minus here. Sorry, A plus B minus. Okay. So A plus and B minus that is it is they are in the form of aqueous form also. We have to write down here aqueous form. So see here in this one solubility product you have to take what only S here. This one as you have to take what S. So this side also you have to take only one S. Why? Because means so here no any 2A B or A to B like it is not there here. So AB that means so only one S you have to take. Next one solubility product at concentration at equilibrium. Concentration at equilibrium. Concentration at equilibrium, what happens here? You see here KSP is equal to so how to write on this one? KSP is equal to that is the A plus into B minus, like that you have to write down. Solid you have to left this one KSP, how you writing? Solid you have to write down. In the last concept only I had told that. So here KSP is equal to A plus into B minus you have to write. So A plus is there means how much is there? S here? S is there. Yes. Here B minus means what you are having? S is there. S into S, that is what you are getting the S square. KSP is equal to what? S square. Here KSP is what? Solubility product, and S is the solubility. S is the what? Solubility of the salt. Solubility of the salt in mole per liter. mole per liter. Here KSP is what? Solubility product of AB type of salt is what? S square is there. Suppose this solubility, how you are writing, sir? Here means the solubility is equal to S is equal to the S is equal to root of KSP. This is the relation between what? Solubility product and solubility. S is equal to root of KSP. This is the what? The example for the AB type of electrolytes. Suppose if you are having the, that is the AB2 type of or A2B. Next one, second one. The second one is what? A2B type. A2B type of electrolyte. A2B type of electrolyte. Suppose if I have the A2B type of electrolyte here means, you see here, the example for the A2B type of electrolyte here. Example. The example is here is the Ag2S. Ag2S and comma. Another one is what? That is the Cu2S. Copper sulfide here. How it undergoing the A2B type of electrolyte? How it is undergoing the dissociation here? When you are adding to water, A2B. When you are adding solid is there this one. When you are adding to the water, then it gives what? Then it gives the 2A plus in the aqueous form. So it gives what? B minus here. That is in the aqueous form. You see here, 2A is there means 2A plus is there means you are written what? 2S. Okay. So here only B is there means you are written only S. Okay. Next one, concentration at equilibrium. Concentration at equilibrium. Equilibrium. What happens here? Concentration at equilibrium. So KSP. KSP is equal to what? KSP is equal to A minus raised square you have to do. That is I have told you here in the definition only. Solubility product here means each stoichiometric coefficient should be raised to the power here. Then what happens here? A minus square into B minus here. A plus is there, sorry. Plus you have to down. So here minus square. Then you have to down here 2S square you have to take. Here 2S is no? 2S square you have to take. And next one you have to write down here into S. So multiply that one. What you are getting the answer? You are getting the answer is what? 4S cube. KSP is equal to what? KSP is equal to 4S cube when we are having the A2B type of electrolyte. Then what is the, you can also write down solubility product. So S is equal to what? S is equal to 3 root cube of KSP divided by 4. This is the what? Solubility product. This is the relationship between what? Solubility product and solubility. This is the what? A2B type of electrolyte is there. Suppose if you are having the next one, third one example, when I am having the AB2 type of electrolyte. AB2 type of electrolyte. AB2 type of electrolyte. Example, AB2 type of electrolyte here means that is CaF2, calcium chloride. Calcium chloride. Okay. This is the example. Calcium chloride, AgCl2. AgCl2. These are the sorry PbCl2. Sorry. PbCl2. PbCl2. These are the example for what? AB2 type. A is the calcium, B is the what? Fluorine here. Okay. So when this AB2 type of electrolytes are there means that you have to write what? How it is undergoing the dissociation? You have to write AB2. So it is in the form of solid. When you are adding into the water, then it gives the product as A plus 2B minus here. Suppose you are having the only A is there means you have to write only one S. Then if you are having the 2B minus is there means you have to write 2S. Okay. So next what you have to do, you see you have to run at concentration at equilibrium. Concentration at equilibrium. What happens at concentration at equilibrium? That is the KSP is equal to solubility product is equal to what? That you have to write down. First you have to write down the reaction. That is the A minus A plus into B minus square. This coefficient should be raised to the power here. Then what happens here? B minus Q here. Okay, square B minus square whatever. Then you have to write down that is as a what? Yes. Here square is there means you have to write down what? 2s square. Then you multiply this one, so you are getting the answer is what? 4s cube here. You are getting the answer is what? 4s cube. KSP is equal to 4s cube. For S is equal to how you are writing? It is also saying S is equal to what? KSP divided by 2. This is the one solved. Next one, we have completed the AB type of electrolytes, A2B and AB2 type of electrolytes here. Next one, next what? That is the fourth one, AB3 type of electrolyte. Okay, AB3 type of electrolyte. Examples are AB3 type of electrolyte here means the examples here for the AB3 type of electrolyte is what? Aluminium trap, aluminium hydroxide. Next one are these are the two examples for what? AB3 type. A is means what? Al. B means what? OH3. So this AB3 type of electrolytes. So when they are undergoing the dissociation, what happens here? Same process you have to run. So that is the okay, you have to run AB3. When this type of salt, AB3 type of salt, when you are dissolving in the water, that is they are in the form of solid, when you are dissolving in water aqueous form, then what happens here? Then what happens? So you see here that it splits into what? It splits into A plus aqueous form, B, how many is there? 3B minus, 3B minus. Like that you have to write every time. So next one, you see here, how many S is there here? Only one S is coming. Okay. So here what happens? The 3S is coming here. Why? Because means so 3B is there now. That you have to write down 3S. Next one, concentration at equilibrium. Concentration at equilibrium. What happens here? KSP, concentration at equilibrium. KSP is equal to what you have to write down here? A plus into B minus raised to the power 3. This should be raised here. Then what happens here? That is what I write down. S into 3S cube. So when you are doing the S into 3S cube, then you are getting what? The answer is 27 S raised to 4. KSP is equal to 27 raised to KSP is equal to what? 27 S raised to 4 when you solve this one. So next one, or. This is also we can write down here is that is the S is equal to 4 KSP divided by 27. KSP divided by 27. So this is the what? Which type of electrolyte? This one. This is the AB3 type of electrolytes. Next one we are discussing. Next type of electrolyte, that is the what? A3B2 type of electrolyte. A3B2 type of electrolyte. A3B2 type of electrolyte. Suppose what is the meaning of A3B2 type of electrolyte is there is here means the example for A3B2 type of electrolyte here means that is the Ca3 PO4 twice. Okay, calcium phosphate here Ca3 PO4 twice. So this is the example for what? This is the example for the A3B2 type is there. A is the what? 3 is there here. B is the 2 is there here. That is the PO4 2. Okay. Next one you have to write down here. That is you have to write down as a A3B2. So it is when it is in the form of solid. This is the one salt is there. A3B2 is the what? One salt is there. All AB, AB2, A2B, AB3. These are the what? One type of salt is there. A3B2 type of when you are dissolving in a water. So then what happens here? Then it dissociates to give what? It dissociates to give 3A plus 2B minus here. 3A plus 2B minus. Then you have to write down 3S. How many A is there now? That you have to write down. Yes. 3A is there, 3S added there. So here how many B is there here? 2B is there. Means you have to write down 2S. Okay. So then concentration at equilibrium. Concentration at equilibrium. Concentration at equilibrium is equal to concentration at equilibrium. What happens here? KSP is equal to, how to write down this one? A plus, you have to write this power here 3. Next one into B minus raised to the power 2. Okay. Then you are writing this one. Then you have to write down 3S here. 3S raised to the power how much is there here? 3 is there. You have to write down 3. Next one 2S is there here. You have to write down 2S. Then you have to raise to the power of what? 2. Then when you are solving this one, you are getting the answer is what? 108 S raised to 5. 108 S raised to 5. That is what? KSP. KSP is equal to 108 S raised to 5 here. So then how we have to write down this one for solubility product for S is equal to? Here means you have to write down here like that here. 5 KSP divided by 108. This is the what? So solubility product and this one is the solubility. So otherwise you have to write down S is means solubility, the KSP means what you have to write down? The solubility product. So this is the what we have discussed about the AB type of electrolyte, AB2 type of electrolyte, A2B type of electrolyte, AB3 type of electrolyte, and this is the last one is what? A2B3 type of electrolyte here. A3B2 type of electrolyte. So these are the very important one here to solve the examples here. So next we will move toward the next one is the problems on the solubility product and solubility. Next when you take the problems. The first one. A saturated solution of solution of silver chloride contains 1.46 into 10 raised to minus 3 gram per dm cube. At 291 Kelvin. What is the solubility product? What is the solubility product? What is the solubility product of the AgCl? Silver chloride at this temperature. At this temperature. You so concentrated on this one. So here is the what? A saturated solution of silver chloride is there. It contains what? 1.46 into 10 raised to minus 3 gram per dm cube at 291 Kelvin. What is the solubility of the product of the AgCl at this temperature? They are asking the solubility product here. Means KSP. How to find out that one? You have to first one gram solution. First you have to write on what? Gram molecular mass. Gram molecular mass of AgCl is what? Gram molecular mass of AgCl, silver chloride. Means you have to write down the atomic weight of silver and atomic weight of chlorine. Add that one. Then you are getting what? Gram molecular mass of AgCl here. So what is the atomic mass of this Ag is there here? Means 107.8 plus 107.8. The Cl is what? 35.5. When you add this one, you are getting the answer is what? That is the 143.3 gram. We are getting the gram molecular mass here. Then next one, when you find out the gram molecular mass, then you have to write down the solubility of AgCl. What is the solubility of AgCl is there? Solubility of AgCl. Solubility of AgCl is what? The solubility of AgCl is, that is our write down 1.46 into 10 raised to 3 gram per dm cube. This is the value, the solubility. The solubility we are found out the gram molecular mass of AgCl. Next one, what you have to do here is, next you have to find out the, that is the, you have to divide that one. 1.46 into divided by 143. When you divide that one, we are getting what? We are getting the value as a 1.46 into 10 raised to minus 3 divided by you have to do what? 143.3. You are getting the answer is what? 1.02 into 10 raised to minus 5 mole per dm cube. This is the value you are getting. So here what you have to do here means the solubility product should be divided by the what? Gram molecular mass. So why you have to divide it, sir? Here means you see the saturated solution they are asking. Saturated means in the classes I had explained what is the meaning of saturated solutions here. So to find out that one here, you have to divide by what? 1.46 into 10 raised to minus 3 divided by 143.3. You have to, when you are doing this one, we are getting the value is what? 1.02 into 10 raised to minus 5 mole per dm cube here. So when you are getting this answer, so at equilibrium, what happens here? At equilibrium, AgCl, it undergoing what? It undergoing the AgCl in the form of solid. It dissociates to give what? Ag plus what it gives here in the form of aqueous form plus Cl minus it gives. At equilibrium, AgCl is dissociated to give what? Ag plus and Cl minus here. Next one, when you are seeing this one, so the Ksp for this one is what? We are done this to which type of salt is there? This one, AB type of salt or AB2 type of or A2B type, or which type of salt is there? When you see this one, which type you are observing that this is the what? AB type of salt is there. In the example also I have given that one. So AB type of salt is there means so the AgCl is a what? AB type of salt. Means if it is actually AB type of salt is there, then what happens here? Ksp is equal to, here we have to write on S, here also we have to write on S. Only one SS. Then it becomes what? S into S. Then Ksp is equal to what? S square. Ksp is equal to what? S square. So we are getting here solubility product. S value we know that one. What is the value there? 1.02 into 10 raised to minus 5 is there here. S value. Then you put that S value here. Then what you are getting? S value is what? 1.02 into 10 raised to minus 5 square. When your solubility product 1.46 divided by 143 when you are doing here, so you are getting what? We are getting what? That is the S value you are getting. This is the what? The S value is here. Otherwise you can also write down S value. How you are getting the S value? That is the solubility of AgCl divided by 143 gram molecular mass when you are doing means, so yes you are getting. That yes you have to fill here. What happens here in this one? 1.02 into 10 raised to minus 5. Then you are getting the answer is what? When you square that one, you are getting the answer is 1.04 into 10 raised to minus 10 mole square dm cube raised to 6. This is the what? Ksp. We are find out at the solubility product of the solution here by using the formula Ksp is equal to S square. Then you have to, every time when you are writing the reaction, you have to see what the reaction is. AB type is there, AB2 type is there, or A2B type is there. That you have to check here. Then when you check that one here means, so it will be easy for to solve this problem here. Next one. Next problem. Next one. The next one is very easy. Is the second problem. Calculate the solubility of calculate the solubility of A2X3 in a pure water, in pure water, assuming that assuming that neither kind of ion react with water, the solubility product of A2X3 in the bracket that KSP is equal to A2X3, KSP is equal to what? 1.1 into 10 raised to minus 23 is there. 1.1 into 10 raised to minus 23. Okay. Then you have what to do? You have to calculate the solubility. In the last problem we have calculated the solubility product. In this one we have calculated what? Solubility. How to calculate this one here means solution. Okay. So first we have to write down A2X3. So when it is undergoing the dissociation, how it is undergoing the dissociation? It gives what? 2A plus 3X minus. Okay. So same manner you have to write down as we saw in the last problems here. So A2X3 is there means so 2A plus 3X minus here. That is how many S is coming here? 2S is coming. 2A is there means 2S. 3B is there means you have to write down 3S here. Okay. Next one, when we are writing the KSP for this one. What is the KSP is there here? KSP is equal to you have to write down A plus raised to you have to raise what? 2 into. So X minus is there. So you have to raise how much here? Stoichiometric coefficient is 3 is there. Then you have to raise the power 3. Okay. So when you have to put here 2S, how much is there? Square is there. Next one here 3S raised to cube is there. You have to write down cube. Then you multiply and solve this one. We are getting the answer is what? That is the 108 S raised to 5. KSP is equal to what? 108 S raised to 5. So when you know the KSP is equal to 108 S raised to 5 here means, then you can write down here S is equal to how to write down this one? Root of 5 KSP divided by 108. Otherwise, it can also be written as what? KSP divided by 108 1 by 5. Like that also we can write down here. Okay. Next one, you put that value. What is the KSP value is there here? That value you have to put here. KSP value. K, they are given 1.1 into 10 raised to minus 23. That we have to put here. 1.1 into 10 raised to minus 23. 1.1 into 10 raised to minus 23. Divided by what? 108 is there. 108. Raised to 1 by 5. Okay. Next one, you solve this one. What is the answer you are getting? When you are solving this one means so you are getting the answer. I will start solving here. 1.1 into 10 raised to 1 divided by 108 here means 1 into 10 raised to minus 25 1 by 5. The 5 5s are 25. Cancel each other here. Then you are getting the answer is what? 1 into 10 raised to minus 5 mole per liter. That is what? Solubility. S is equal to what? 1 into 10 raised to minus 5 mole per liter. So when you are finding the KSP, you can also find out that is the what? Solubility here. What is the relation between solubility? Is for each type of salt it is different is there here. AB type is different, AB2 type is different, and AB3 type is different is there. So next one we will discuss about the conjugate acid base pair. That means conjugate acid base pair. What is the meaning of this conjugate acid base pair here? Means the pair of acid and base differ by the only one proton. The pair of acid and base differ by the only one proton. That is what we are going to say conjugate acid base pair. Suppose the example is the HCl is there. HCl, when you are adding into the water, that is the what? H2O. So then it gives what? Then it gives the H3O plus it gives the Cl minus here. So this is what acid is there. Acid 1. This is the what? Cl minus acts as a base 1. So this one it acts as a acid 2. This acts as a what? Base 2. Okay. You see here the HCl is the acid, this is the base is there. So these HCl and Cl minus they differ by what? Only one hydrogen. Then it is what? The HCl and Cl is the conjugate acid base pair. Suppose you see here H2O is there and H3O plus is there. They differ by what? Only one hydrogen. Then it is called what? Then it is called as a conjugate acid base pair. What is the meaning of conjugate acid base pair is there, sir? Here means the acid and the pair of acid and base differ by a hydrogen, differ by a proton. One proton, differ by a proton. So a pair of acid and base differ by a proton. That is what we are calling a conjugate acid base pair. The example for conjugate this one only you can, by seeing the reaction you can write down here is the HCl is there and Cl is there. HCl and Cl is a what? Conjugate acid base pair. And next one, another one, H2O and OH minus. These are what? Conjugate acid base pair. So these are the what we call conjugate acid base pair. What is the meaning of conjugate acid base pair? They are differ by what? They are differ by only one proton. The acid and base, the pair of acid and base differ by the only one proton. That one we are calling what? Conjugate acid base pair.